I decided to do my final project on apportionment, which is the problem of dividing up a fixed number of things among groups of different sizes. In its most basic sense, apportionment is a type of arithmetic since it involves division. It's not as simple as putting things in equal groups, however. In politics, this takes the form of allocating a limited number of representatives amongst voters. This problem is older than the United States, but the best known ways to solve it have their origins in the problem of assigning each state an appropriate number of representatives in the new Congress when the country was formed. States also face this apportionment problem in defining how to draw districts for state representatives. The apportionment problem comes up in a variety of non-political areas too. There are many guidelines that need to be followed when doing an apportionment problem depending on the context and application of it. The things being divided up. These rules include things being divided up can only exist in whole numbers. We must use all of the things being divided up and we cannot add any more. Each group must get at least one of the things being divided up, and the number of things assigned to each group should be at least approximately proportional to the group population of the group. Exact proportionality isn't possible because of the whole number requirement, but we should try to be as close as possible. If Group A is larger than Group B, then Group B shouldn't get more of the things than Group A does. Almost as soon as the first census was completed in 1790, many political thinkers, including Alexander Hamilton and Thomas Jefferson, began suggesting their own methods. Since the Constitution did not specify a certain method of apportionment, different methods may be used for different measurements. Until the middle of the 20th century, Congress enacted a new apportionment legislation following almost every census. Now, Hamilton's method determines how many people each representative should represent. You do this by dividing the total population of all the states by the total number of representatives. This answer is called the divisor. You divide each state's population by the divisor to determine how many representatives it should have. Record this answer to several decimal places. The answer is called the quota. Since we can only allocate whole representatives, Hamilton's resolve the whole number problem is as follows. Cut off all the decimal parts of all the quotas, but don't forget what the decimals were. These are called the lower quotas. Add up the remaining whole numbers. This answer will always be less than or equal to the total number of representatives, and the or equal to part only happens in very special cases. Assuming that the total from step 3 was less than the total number of representatives, assign the remaining representatives one each to the states whose decimal parts of the quota were largest until the desired total is reached. The problem with this method is that Hamilton's method is subject to several paradoxes, as 3 of them happened on separate occasions when Hamilton's method was used to apportion the United States House of Representatives. The Alabama paradox is named for an incident that happened during the apportionment that took place after the 1880 census. Then the New States paradox happened when Oklahoma became a state in 1907, and the population paradox happened between the apportionment after the census of 1900 and 1910. Next is Jefferson's method, which determines how many people each representative should represent. To do this by dividing the total population of all the states by the total number of representatives. This answer is called the standard divisor. Divide each state's population by the divisor to determine how many representatives it should have. Record this answer to several decimal places. This answer is called the quota. Cut off all the decimal parts of all the quotas, but don't forget what the decimals were. These are the lower quotas. Add up the remaining whole numbers. The answers will always be less than or equal to the total number of representatives. If the total from step 3 was less than the total number of representatives, reduce the divisor and recalculate the quota and allocation. Continue doing this until the total in step 3 is equal to the total number of representatives. The divisor we end up using is called the modified divisor or adjusted divisor. Webster's method. Next is Webster's method. Determine how many people each representative should represent. Do this by dividing the total population of all the states by the total number of representatives. This answer is called the standard divisor. Divide each state's population by the divisor to determine how many representatives it should have. Record this answer to several decimal places. This answer is called the quota. Round up or down all the quotas to the nearest whole number. Add up the remaining whole numbers. If the total from step 3 was less than the total number of representatives, reduce the divisor and recalculate the quota and allocation. If the total from step 3 was larger than the total number of representatives, increase the divisor and recalculate the quota and allocation. Continue doing this until the total in step 3 was equal to the total number of representatives. The divisor we end up using is called the modified divisor or adjusted divisor. Here's an example of Hamilton's method. Here's an example of Jefferson's, Webster's, and Huntington Hill. Now, apportionment is the process of dividing the 435 memberships or seats in the U.S. House of Representatives among the 50 states. At the conclusion of each decennial census, the results are used to calculate the number of House memberships to which each state is entitled. This map shows the changes to the number of congressional seats for each state between apportionment based on the 2010 census and apportionment based on the 2020 census. Next is a chart of the changing ranks of states by congressional representation. The number of representation given to each state as a result of apportionment has shifted over time. Shifts in political representation are due to change in state population relative to other states, the admission of new states to the Union, and increase to the total number of memberships in the U.S. House of Representatives instituted by Congress over the decades. 7 states with the largest number of representatives in a given year are included in the graph, beginning with the Constitutional Congress in 1789, prior to the first decennial census, and following each decennial census from 1790 through 2010. Now, why was this topic so important to me? It had some applications to the field of law and criminal justice, which is my major, and I'd like to become a lawyer one day. Apportionment also involves the distribution of fair shares and related to money or property, and it helps to ensure that things are fair and even in every context is complied. Apportionment is also used by schools, governments, business owners, and accountants, among other professions. I'm interested in studying apportionment because it is a mathematical concept that has many important applications in the real world and therefore will be useful to be more informed about. That is my presentation. last thing I have are my sources. Thank you for your time.